but let us get into our area question. All right, so this is just, and I would, if you didn't take this down on Monday's lesson, I would take a quick screenshot of these formulas that we have here. Now, these formulas are how we can determine area of different shapes. Come off task and back in again. So these are our formulas to work out the area of our different shapes. We spoke about this on Monday, so I'm not going to go through them again. If you are unsure of any of these formulas, please make sure, guys, it's so hot in the Western Cape. I'm so tired this heat. So I apologize. All of these formulas are how to work out the area of these shapes, and essentially what you need to be able to do is be able to look at a shape or look at a picture or a diagram that you've been given and be able to apply these formulas correctly depending on the information that you have. So again, we did this on Monday. If you weren't here on Monday, if you have forgotten, if, like I say, you didn't get it down, here is sort of the summary, but I would definitely go back and watch the Monday's video just to get a basic understanding of our area. All right, so area of a square, side times side or side squared, area of a rectangle, length times breadth, area of a triangle, half base times the height, and an area of a circle, pi r squared. Now, grade 8s, please remember that area is the amount of space that a 2D shape occupies or that a 2D shape takes up. And then very importantly as well, we need to remember that area is measured in units squared. So whenever you're giving your answer, whenever you're working out your answer, you always need to have units squared in your answer because it's an area. Again, I explained why this is the case on Monday, so go and have a look at the video if you need to for that explanation. Right, but let's have a look at some examples. If you haven't taken a screenshot, I suggest you do so. In terms of screenshots, if you don't know how to do it on your device, what I suggest you do is you just take your phone and take a picture of the screen. At least then you have it. It depends on the device that you're using of how to screenshot. So the easiest way for everyone to be able to do it, just take a photo of the screen. Alrighty, guys, but let's have a look at. I don't know why my examples are a bit all over the place, but we're just gonna roll with it. All right, so the first example that I have here, and remember, guys, the whole point of this lesson is to step up the area calculations. So they're not going to be necessarily super straightforward calculations, but they're ones that we can do. So the question says the area of a square is 42,25 centimeters squared. Determine the length of the sides of the square. Now, what I would do is, especially if you struggle to visualize what's going on in a question, I would draw my picture for myself. Right, so I've been told that I have a square, and so that means that all of my sides are equal in length. Obviously, I also have my 90-degree angles here, but we don't really care about angles when it comes to area. We care more about the fact that those sides are all the same length. We have been told what the area is. So I have told you that the amount of space that this shape takes up is 42,25 centimeters squared. Now, if we read this question again very carefully, what it's asking us to do is it's asking us to determine the length of the sides of my square. Now, what that means is I'm looking to know what these side lengths are. Now, if it's a side length, remember that this is just a centimeter answer. A length just measured as centimeters. Area is centimeters squared. So what I'm asking us to do is I'm asking us to go backwards. I've actually given you the area. I need us to go back and figure out what the side was. So remember, the area of a square is found by saying side squared, or you can say side times side. It doesn't really matter. Let's just make that S a bit better. And because we know what the area is, we could actually substitute that value in. 42,25 is equal to side squared. Now, my goal is to determine the side length. So I want S. I don't want S squared, I want S, which means I'm going to have to square root both sides of my equation. And once you've done that, you will have gotten a value of your side length, right? So when I, whoopsie daisies, when I square root 42,25, I get a side length of 6,5 centimeters. And so what we've been able to do here is we've been able to work backwards from the area and work out the side length. And again, grade 8, the point of this lesson is to just step things up a bit with the area. And so this is the type of question we would be able, or we should be able to expect you to do. So when I give you the area, you're working backwards to determine an unknown dimension. Now remember, you can go and check yourself. So if you weren't 100% sure that this answer was correct, go and check yourself using your area formula. So your area, you know, is equal to side times side or side squared, doesn't really matter. And now that you've worked out your side, go on your calculator and double check that 6,5 squared is equal to 42,25 centimeters squared. And because it's the same answer as what we were originally given, my side length is correct. All right, so again, the type of question that you can be asked to do. Got a question here, please repeat from the line number 3. So I'm assuming this is line number 3 over here. So what we have is 42,25 is equal to side squared. Remember, we're looking for the side length. We're not looking for the side length squared. So we would need to square root both sides in order to cancel out the square and leave me with just the side length. And when you square root 42,25, you get 6.5 centimeters. So through inverse operations, we were able to go backwards and solve for the side length. And again, something I would definitely expect you to be able to do with these sorts of questions. The stuff in green is then just a check for yourself. You don't have to write the check down. You can just do it on your calculator. But there is a way for you to check your answer. Right, so let's take a screenshot of that, and then I'm going to move on to the next example. Remember, guys, if you have questions exactly as you just saw now, put them on the chat, and I will answer them as soon as I'm finished with an explanation, or as soon as we have a break in proceedings. Good, guys. All right, so if we have a look here, I have said to you again, and let's just read our question nice and carefully. I have said to you that a square has an area of 52,56 centimeters squared. I am asking you to go and determine the length of the side of the square. So basically exactly the same question. I've just used a different number for my area. I have said round off to 2 decimal places, so just bear that in mind. But I want you guys to try this. This is basically exactly the same question as what you just had. You've been given a square. I've told you what the area of that square is. I want you to now go backwards and work out what the side length is. The square is horrible, so we're just going to ignore that. So I want you to try by yourselves. Here's your square. Because it's a square, you know that all your sides are equal. You have your 90 degrees, which again, we don't really care about when it comes to area. We care about that more in geometry. And I've told you that this whole area of my square is 52,56 centimeters squared. So I want you to go back, or I want you to sort of work backwards now and figure out what these side lengths are. Like I say, it's the same question, I just changed the number. So if you're feeling a bit stuck, go back to your screenshot, look at what we did in the last example, and let's see what we get. And remember, 2 decimal place rounding off. Guys, this is a length, so your units is not squared, it will just be centimeters. Squared is only if you're looking at an area. If you're determining the length or the distance, it is just units. So just centimeters, just millimeters, whatever units you're working with, Units squared only comes in when it's area. Good. Keep those answers coming. Good, guys. Okay, so let's have a look. Like I say, it's the same thing, exactly the same. So we know that the area of a square is equal to side squared. We know that the area is 52,56. So that is equal to side squared. And then as I explained earlier, we don't want side squared, we want the side. So what we need to do is we need to square root both sides, English, so that I get rid of my square root. And if we square root 52,56, we get a whole long decimal. So we get that the side is equal to 7,249827, and there's a whole bunch of numbers after that. Now, guys, remember that I've said round off to 2 decimal places. We've had this discussion before, but if we tell you to round off to a certain amount of decimal places or to a certain number, you have to do that. In your test or in your exam, there will then be a mark for that. And so if you don't do it, you will lose that mark. So to 2 decimal places, I want to stop 2 numbers after my decimal. This 9 rounds the 4 up to a 5, so 7,25. I know it's in centimeters because that's what my area was in, and because it's just a length, it's just centimeters. It's not centimeters squared, anything like that, just centimeters. Right, so again, we need to be able to work backwards from a given area. So Bokang's asked, how many marks will we get for this particular question? So I'd probably give you a mark for subbing in the area. So knowing that it's area equals side squared. I could give you a mark for the square root and then a mark for your answer that has been correctly rounded off. So 3 marks might not seem like a lot, but if you think of it in terms of a 50-mark test, 3 marks is 6%. And so just by doing these 3 things, you've earned 6% in a 50-mark test. So all of these things add up. All of these little questions add up to get us, hopefully, the mark we want. Seth has asked, would you get marks if you check? No. You will only get marks if you check if the question then asks you. So say, for example, this was like 1.1, and then 1.2 said, check your answer through substitution or something. Then we would give you marks. But no, a check is just for yourself to make sure that you've done it right. To be so very similar steps, yeah. So any shape, if I give you the area, you will have to then solve for one of the other dimensions that you don't know. So yeah, very similar working out. Right, guys, so let's take our screenshots. If anyone has any questions at this point, you're welcome to raise your hand. Otherwise, let's take screenshots and then we're going to move on to our next question. Okay, nice, grade 8s, and good questions that we're asking. Oops. So if we have a look at question B, and I apologize for the weird squares on squares thing. I don't know what happened, but we're just gonna be okay. If you have a look at question B, I've now asked you to determine the area of the shape that we have been given. So firstly, area means that I want all the space that this sort of T-looking shape takes up. Now, we don't have a formula for a T-looking shape. If we go back to all of our formulas, we've got a formula for a square, for a rectangle, for a triangle, and for a circle. Nowhere do I have a formula for the area of a strange looking shape. And so exactly as Nomsel said there on the chat, we break up our shape. Now, when I say we break up our shape, I mean break it up into a square, a rectangle, a circle, or a triangle. It will depend on what you have. And so you need to go and have a look at your diagram or whatever you've been given to determine how you should break it up. But if we break it up into a rectangle, we know how to work out the area of a rectangle. If we broke it up into parts of what it is, we can then just add all those areas together. Right now, excuse me, there are lots of different ways that you can break up a shape. My advice is try and keep the number of shapes you break it up into at a minimum. So this technically could be broken up into 3, 4 different rectangles. But why then do 4 calculations? It is so much easier to break it up into the minimum amount of shapes that you can in order to work out your area. So what I would do to break up the shape is I would just consider this long rectangle at the top and the slightly shorter rectangle at the bottom. That's 2 rectangles. I know the formula for the rectangle. I can work out the 2 areas and I can just go and add them together. Okay, so when we get a complex shape like this, break it up into parts and then you can go and work out your areas separately and add them together. Right, Natalie, I did show it earlier, so you should have taken a screenshot. I've shown it a few times, so you'll just need to hang on for a little bit and then I will give you the area in a second. Okay, so guys, how you then choose to set up your working out is up to you. I like to label my shape. So I would call this rectangle A, and then I would go and say this is rectangle B. If you want to call it rectangle 1 or rectangle 2, whatever, it makes no difference. For me, I just like labeling it so that I can make sure that I have actually done all my calculations. Right, so if I want the area of rectangle A, we know that the area of a rectangle is length times breadth. And so we need to go and work out what the length and the breadth of this rectangle is. Now we can very clearly see that the length is 15, so that's not a problem for me. And I can very clearly see that the breadth, or how wide this rectangle is 3 centimeters. So not a problem. Easy peasy. I can go and multiply those 2 values together and I get 45 centimeters squared. Now remember, this is an area, so it will be squared, but we have worked out this first area of rectangle A. Now I can go and work out the area of rectangle B. And again, what I need is the length and the breadth. Now guys, be careful, right? You don't know what this length is, nor do you know what this breadth is. We're gonna have to go and sort of use the information we already have to figure that out. All right, so if we go and have a look, if we go and have a look and see, okay, I need firstly the length, or how tall my rectangle is. I know that up to this point is what I'm looking for, but this whole line that I have here is 9 centimeters. I also know that this top width of my top rectangle is 3 centimeters. So if this top width is 3 centimeters and the total should be 9 centimeters, what I have left at the bottom here is then 6 centimeters, because 9 plus 3 gives me 9 plus 3, 6 plus 3 gives me the 9 centimeters that I'm looking for. And so again, we use the information that we have in order to work out the missing dimensions that we need. So now we've got the length, that's 6 centimeters. We now need this width at the bottom. We know that the whole width is 15. These little side, or these little bottom overhangs are each 4 centimeters. And I know that because of this line on them telling me that they're equal. And so if I say 15 minus the 4 on either side, 15 minus a total of 8 centimeters is a width of 7 centimeters. And so my width here, my breadth is 7, giving me an area for this bottom rectangle or rectangle B of 42 centimeters squared. Now, once I have all of that, it's easy to work out my total area. My total area is saying the area of rectangle A plus the area of rectangle B. And because we have both of those answers, that's easy. 45 plus 42, giving us a total area of 87 centimeters. Cool. 87 centimeters squared. So guys, I just don't know why it went all wiggly, but it doesn't matter. When you are doing these types of shapes, what you need to be able to do is you need to be able to break your shape up into shapes that you know how to work with. Rectangles, triangles, squares, etc., etc. And then you need to be able to work out the area of those individual shapes to then add together. Alrighty, so if anyone has any questions, now's the time to raise your hand and ask. If you don't have questions, please make sure you take screenshots. There's a question on the chat of, can I please explain how I got the 7? Absolutely. So if we have a look here, this whole top length is 15 centimeters. I have also been told that this sort of overhang is 4 centimeters and it's the same on both sides. So if I know that this portion at the top is 4 and this portion at the top is 4, I need to figure out what I'm missing in the middle. Now we've got 4 plus 4, which is 8, and I need to make up or need to ensure that I make up 15 centimeters. 15 minus the 4 on the side minus the 4 on the left-hand side gives me the 7 centimeters at the bottom. So it's through a process of subtraction that we're able to get the 7 centimeters for the bottom width. Right, guys, I really need us to listen because I can't be repeating what I've already explained, all right? And you know this. Please repeat the whole area of rectangle B. I've already explained how we got the 7 centimeters, so I'm not doing that again. If we go and have a look at the 6 centimeters and how I got the 6 centimeters, we know that the whole height of this T shape is 9 centimeters. I know that the width of my top rectangle is the 3 centimeters. And so if I know I've already got 3 centimeters at the top here, and the whole thing must be 9, I'm left with 6 centimeters, which means I've got a 6 by 7 rectangle that I need to go and work out the area of. Hence why I said 6 times 7 for the area of this rectangle. All right, so the complexity here comes in you being able to find the missing dimensions, but you use the information that you have. We're never going to not give you enough information. There will always be enough information for you to figure it out. Okay, so I hope we're happy. Again, questions on the chat, or you can raise your hand. There was a question from someone of please give us harder questions. These are harder questions. All right, so you can do these. You should be able to do anything that measurement throws at you. Okay, so Nokutenda and Lindor, I hope we're fine with those answers. I'm moving on to the next question now, so I hope we've all got our screenshots. Before I do that, I'm going back up to the formulas. So Natalie, the area of the circle is here. Please take a screenshot of this grade 8. I'm not going to come back to this. So please take a screenshot so that you have these formulas that as we go through our examples, you can actually do them. Okay. Right, so let's have a look at question D, mostly because someone asked, I can't remember who now, you'll have to correct me, but someone asked if we would do the same sort of calculation with a circle as we were doing with squares earlier on. So this question specifically tells us that the area of a circle is 320 centimeters squared, and I am now asking you to go and determine the length of the diameter. All right, so a couple things that we obviously need to bear in mind before we do this. First things first is what are these parts in a circle? So obviously the area of the circle is how much space the circle takes up. I just want to move that up a bit. When it comes to diameter, please remember that your diameter is the line that passes straight through the center of your circle, touching either side of your circumference. So this line here, whoops, it would help if I could spell diameter. This whole line here from one end of the circumference to the other through the middle is your diameter. Half of your diameter is your radius. Okay, so very, very importantly, your diameter is equal to 2 radii. Radii is the plural of radius, and vice versa, the radius is equal to half the diameter. Okay, so these are important things to know as we go and answer this question, because we have been asked to work out the diameter. Now, really importantly here, guys, is we were given the area. Now, the area of a circle is equal to pi r squared. And I have given you the area of the circle. So what we're going to do is we're going to take the area that we know and we're going to sub it in. So we know that the area is 320 centimeters squared, and that would be equal to the pi r squared. Same as what we did with the square, exactly the same. Okay, you're subbing in and you're going to solve for your unknown. Now, what we need to realize, grade 8, is the fact that I can't get the diameter straight away. I can get the radius because my formula involves radius. And then once I have the radius, I could just times it by 2 in order to get my diameter. So just because I'm solving for my radius doesn't mean that I'm doing anything wrong. We have to understand what the radius and diameter's relationship is. Okay, so we're solving for r. The first thing that I'm going to do is I'm going to divide both sides by pi. Please remember, grade 8, that pi is a number. We just use a symbol to represent it because its decimals go on for infinity. We can't write down all of its decimals. So it is actually a number. We just use a symbol to represent it. So what I now have is the fact that 320 divided by pi is equal to r squared. Now again, same as the square. I don't want r squared. I want r. So we're going to square root both sides in order to get rid of that squared. Now, unfortunately, because you're using pi, you are going to have a whole long decimal that you're just going to have to deal with. It is what it is. Make it work. Right, so the square root of 320 over pi is equal to, so this is r is equal to 10,092530, and there's a, oh, sorry, there's a whole bunch of decimals. Now remember, grade 8s, we were asked to determine the diameter of the circle. What we have worked out is the radius. So what we need to do is we need to take our radius and times it by 2 in order to get our diameter. So we take this answer that we just got, we multiply it by 2, and we get that our diameter is equal to 20. Okay, sorry, my calculator is just fighting with me. And we get 20,18506 060, and there's a whole bunch of decimals. Again, we would need to round off. Generally, it's always to 2 decimal places, so the diameter is 20,19 centimeters in length. So again, grade 8s, thank you, Kenya. Again, grade 8s, this is like the question itself is made up of very few words and very few instructions. The complexity comes in understanding what the radius's relationship with the diameter is, and understanding how to then use your formulas that we know. Mongo, how did I get the 20? Sorry. So just to reiterate that point there, we've worked out the radius is 10,09 blah, blah, blah. Remember that your radius is 2 times the diameter. Your diameter is 2 times the radius. Because we were asked for the diameter, we need to now times that answer by 2. So the way I got my 20,19 was I took this 10,09 blah, 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 and I times it by 2 because of this relationship. And then I got my answer of 20,19. Butle, how did I get the radius? So remember, it was through substituting into my formula, area equals pi r squared. Divide both sides by pi, leaving me with the r squared. And remember, I don't want r squared, I want r. So to get rid of the squared, I need to square root, leaving me with radius. Bongo, no problem, absolutely. Okay, Nonkutano, I'll get my calculator out now and we'll go through how to do this. I'm little concerned of why that is the case. What I want you to do for me, I see Tatenda's hand is up, so I'm going to answer that. Nonkutano, what I want you to check is that at the top of your calculator screen, like there's a whole bunch of stuff that might be highlighted. I want you to make sure that the D is highlighted. If it isn't, that might be the problem. I'll show you this now, but I want you to have a look in the meantime. Tatenda?
Hello, ma'am.
Hi.
Yes, ma'am. I took 320 to square root.
Okay,
But
so
it's
remember,
giving
you
me.
have to divide by pi first.
Oh, okay, ma'am. I understand.
Okay. Okay. So guys, what Tatenda said there, pi is essentially your coefficient. So we need to get rid of that coefficient first before we do the square root. Alrighty. Okay, so okay, so it is. So guys, if you don't know what I was talking about, like right up at the top here, there should be a D highlighted. That means you're working in degrees, which is what we work in geometry. And so if that isn't highlighted, sometimes you do get weird answers. But let's see. Okay, so the first thing that we would do is we're going to say 320 divided by pi. Okay, that gives me that whole 101 blah, 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 which is 320 over pi. The next thing that I want to do, according to my inverse operations that I've written down, is I want to square root that answer. Oh, golly, sorry, I can't do it backwards. Square root that answer of 320 divided by pi. And once you square root that, you get the 10,0925 blah, 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 which is this answer down here in the purple. That is your radius. You now need to times it by 2 in order to get your diameter 20,1850 blah, blah, blah. Okay, so do it step by step. I hope what you guys also saw is that I'm using answers. So at the bottom of your calculator, you've got an answer button. Your calculator automatically stores your last answer. So you just push that if you want to use your answer in your next step. I wonder, how do you get pi? Okay, so we have had this discussion before, so I'm not going to spend a lot of time on this. Pi is above the times 10 to the power x. There's the pi in yellow. So what you need to do is you need to say shift, and then you push that button and you get pi. If for whatever reason you don't have pi on your calculator, 3,142 is the value of pi that we use. No problem. Okay, guys, so there is a fair amount of calculator work that you need to be able to do. And honestly, as you move up in maths, even maths lit, you need to be able to use your calculator. I know that in primary school, a lot of teachers don't use a calculator, even sometimes in grade 8. I don't see the point of it, but that's my personal opinion. So it is important that we start becoming comfortable with our calculators. Alrighty, so I hope you've all taken screenshots of this. I will just wait another second or two just in case. Okay, but Butle, I've just explained it, so I'm a little bit confused why we're not listening. I'm doing it one more time. 320 divided by pi gives me 101,85 blah, blah, blah. That is your radius squared. We need to square root that answer, and that gives me the 10,09. So it's from the square rooting. That's where we get the 10,09525, whatever it is. no, non-cotanal pi is 3,142. There you go. Pi, 3,141592, blah, blah, blah. Okay. I'm going to give you a 2-minute break. We're not doing a whole brain break, but this has been a lot of information. So take 2 minutes, get up, stretch, move, run to the bathroom if you need to. And then we're hopefully going to do one more question. We'll see how we go. But yeah, have 2 minutes and then we're going to carry on in 2 minutes. To be so, I mean blah, blah, blah when I don't want to say all the numbers. I just get lazy. So think of my blah, blah, blah as the dot, dot, dot with all the decimals. I just don't want to say all the numbers. I'm being lazy. This Kia, very nice. How did it go? How did the paper go? Yay, I'm so glad to hear that. Well done. I'm sure you studied really hard, so hope you're proud of your marks that you get. Well done. You are really getting into the swing of exams now. I know some of you are probably already almost halfway through your exams. Vissel, good luck. Kenya, good luck. Lino, well done, good luck. Guys, got it. And remember the videos. Go back and watch the geometry videos. Okay, it's really helpful. Logan, we're not doing the whole brain break, just because we don't have that amount of time, but I'm just giving you a little break now. We're going to carry on in a minute. Bali, good luck. Venati, not as bad, good. Otile, nice. Good. I hope that the lessons are helpful, and just remember everything's recorded. So go and watch them when you're studying. Right, guys, on that note, let us get into this. I'm going to ask you to try this one by yourselves because this is very, very much the same question as what we had earlier with the square. Right, so on the chat, let's just focus, please. Break is over, and good luck to everyone who is writing. So it says the area of the rectangle below is 37.5 centimeters squared. So I'm telling you what this area is. I am then asking you to go and determine the value of B. Now let's look at where B is. B is the length of my rectangle. I've given you the area. So I want you guys to try this one by yourselves. Let's see what we come up with as our answer. If you're feeling a bit stuck, go back to the very first example that we did with the square. Basically the same thing, it's just now a rectangle.
Let's go, my people!
Yay! And remember, guys, you can check if you want. So once you have B, double check that B times 5 does actually give you 37.5. So remember, I showed you that there's a check. B is also a length, so I'm really glad to see that you guys are just using centimeters and not centimeters squared or anything strange like that. Nice, grade 8. Well done. Okay, excellent. So we know that the area of a rectangle is length times breadth. We know that the area is 37.5. We don't know what the length is. That's the B value that I'm trying to find. But I know that the breadth or the width is 5. Now, using my inverse operations, I know that the opposite of multiplication is division. So if I divide both sides by 5, I'm able to solve for that value B. Now, 37.5 divided by 5 is 7.5 centimeters. And that is my value for B. You do not have to write the B all fancy like that. It's just a habit that I have. A normal B is absolutely fine. All right. Like Tabiso said, if we do a quick check, so if we now say 7,5 times 5, you will get 37.5 centimeters squared. That's the area that I gave you, so you have done your calculations correctly. And grade 8, I can't stress this enough, like in your exams that some of you have coming up, check. When you're sitting with that last 10, 20, 30, hopefully not 30, but when you're sitting and you have time, go back and check everything that is possible to check, right? This is how you catch the silly mistakes that you make. Everyone makes silly mistakes, but this is how you catch them, by using your time effectively towards the end of your exam when you're sitting doing nothing. Good, okay. So let's take a screenshot of it. I'm hoping we're going to get one more in. Remember, guys, any questions as we go along, just ask. I just want to see what my next question is. Right. So question B, don't know if I've now made this. No, there we go. In the diagram below, and for me, colors help. A, B, C, D. So A, B, C, D is the big rectangle on the outside. And E, F, G are both rectangles. So E, F, G, the smaller rectangle on the inside of my diagram. So they're both rectangles, which means I can assume everything about a rectangle is true. We have then been told that BC is equal to 14 centimeters. So this length down at the bottom is 14. We have also been told that CD is equal to 8 centimeters. So this length down the side here. And that EF is equal to 6 centimeters. EF being the smaller rectangles, a side length. I am telling you, and that's very important that we read carefully, the area of the shaded region is 64 meters squared. So the area of the shaded region is all of this around the inner rectangle there. Is 64 centimeters squared. Determine the value of y. And y is essentially the length of the inner rectangle. Right, so this is quite a lot of information going on here. So the first thing that I want you to realize is that the shaded area would be found by taking the big rectangles area, so rectangle A, B, C, D's area, and then subtracting the smaller rectangles area, rectangle E, F, G, H's area. Right, so that's how I'd get the shaded region. If I took the big rectangle and then subtracted the smaller one, I'd be left with that shaded area around it. So that's the first thing that we need to realize. And because I now have this equation for myself, I can now start to substitute in what I know. So we know that the shaded region or the shaded area is 64 centimeters squared. So I know that. My blue or my bigger rectangles area would be 14 times 8, length times breadth, minus my smaller rectangles area, which would be the y that I'm looking for. times 6, length times breadth. And through understanding how to work out the shaded area, I've set up an equation that I can go and solve for y. Alrighty, so if we now go and do exactly that, 64 is obviously 64. 14 times 8 is some fun value, 112. Minus, and 6 times y is 6y. Inverse operations, glad to see that we're already trying, means that I'm going to have to subtract 112 on both sides. So 64 minus 112 is equal to the minus 6y, because remember we want to get the y value alone. 64 minus 112 minus 48 is equal to negative 6y. And again, inverse operations tells me that I'm going to have to divide both sides by negative 6 in order to get the y alone. And as you guys are beautifully put in there on the chat for me, that therefore means that y is equal to 8 centimeters. Okay, so shaded region questions like this one, we love. These are complex questions, all right? So the harder type of questions, but a shaded region question, love to ask you that. So it's really important that we know how to work out a shaded region. And guys, shaded areas will always be the biggest shape minus the shapes inside that we need to take away to get the remaining shaded area. Okay, so let's take our screenshots of this. If anyone has any questions, now is the time to raise your hand and ask.